The effects of saltwater corrosion.
What is this project about? Our project focuses on the effects of saltwater intrusion and its affects local infrastructure, leading to corrosion and structural damage in coastal areas. The environmental impact is that saltwater often can weaken bridges, roads, and buildings, necessitating expensive upkeep and repairs. Additionally, it disrupts communal water supplies and local ecosystems. The role in chemistry is understanding how the corrosive effects of saltwater on objects such as metal and construction and concrete requires an understanding of chemistry. Over time, structural materials may become weaker due to chemical interactions with saltwater. Determining these processes aids in creating safeguards.
Meet the team. So our team of four aspiring engineers includes Joe Borden, our team manager, Vanessa Gil, our team facilitator, me, Daniel Urhbrock, our product manager, and Omar Toeama, our research facilitator.
I'm Joe Borden, the team manager. I'm a civil engineer major from Beaumont, Texas. As the team manager, I ensured all group projects were completed well and on time. My input on the quality of our work has proven to enhance the quality and timeliness of our work. The thesis I proposed would investigate the different ways civil engineers build flood-resistant infrastructure and housing.
Howdy, my name is Vanessa Gil. I am a petroleum engineer from Houston, Texas. My efforts as a team facilitator have allowed us to expand on several helpful ideas to the project. I have taken the initiative to organize and suggest meeting times and group deadlines, ensuring that everyone stays on track and everything aligns with our goals. The thesis I proposed was how does offshore drilling near Galveston Bay and the Gulf of Mexico impact local marine ecosystems?
Howdy, my name is Daniel Urhbrock. I'm the product manager for this group, and I'm a computer science major from Dallas, Texas. My role as the product manager was particularly helpful in guiding team members on the content of our video presentation, as well as polishing the slideshow and helping with the editing of the video file. My thesis proposal involved ideas aimed at protecting coastal environments using structures such as seawalls or dikes.
Howdy, my name is Omar Toeama, and I'm a highly distinguished civil engineer from Houston, Texas. My contributions as a research facilitator ensured that we had access to comprehensive and relevant information. My thesis proposal was how to reduce the effects of saltwater on local infrastructure.
So some problems we faced throughout this group project was scheduling and communication. We resolved these problems by utilizing group chats as a means of communication and sharing calendars to make sure we knew when due dates were and some deadlines that were important to us. Another thing that helped a lot with the communication was just making sure that everyone knew what was needed to be done and what they needed to do, and also avoiding overlap or missed tasks. Because also we avoided overlapping and missed tasks throughout this.
Our findings during the boat trip included several locations, such as the SS Selma, Pelican Island Bridge, and the oil rig. Which of these we've decided would best fit our project? The bridge is an example of exposed materials to corrosion, such as metal, caused by saltwater, and showing that even saltwater can affect major infrastructure. The oil rig shows how protective coatings on metal help reduce corrosion. The Selma is a reinforced concrete ship with metal rebar and shows the effects of corrosion on exposed materials that are commonly found in other forms of infrastructure. These locations displayed effects of corrosion and methods used to combat them. The corrosion is an electrochemical reaction where metals are oxidized. In the presence of water and oxygen, metals like iron form rust, iron oxide. Zinc corrodes more easily than iron or steel, making it ideal for galvanic protection. It acts as a sacrificial anode, being oxidized completely before other metals, protecting the valuable iron steel hulls of the structure. Our boat trip, on the boat trip, we saw the SS Selma, a concrete ship that had none of these protections against electrochemical reaction of corrosion on seawater. We saw a fixed oil rig platform. Its steel base was exposed to seawater since its construction, yet the corrosion is very minimal compared to the Selma. This is because the oil rig utilizes sacrificial anodes in their paint coating, similar to using a metal like zinc. These coatings serve to protect structures from the dangerous corrosion that takes place near the coast. Utilizing knowledge from chemistry, engineers can prevent corrosion of metal structures and foundations near coastal areas. This knowledge of chemical reactions saves countless lives.
Now for scientific evidence from our sources. Some of the scientific evidence from our sources include corrosion challenges in coastal facilities. See, coastal environments accelerate corrosion due to things like high salt content in the air, elevated humidity levels, temperature fluctuations, and mechanical wear from wind and waves. These factors compromise the structural integrity and operational reliability of facilities near these coastal areas.
So, continued of our evidence from the literature that supports our theses. There are several different effective coatings, some acting as sacrificial anodes and also others acting as protectants from things like UV rays or uh, other forms of wear found in a hot, humid coastal environment. Epoxy coatings have excellent adhesion and chemical resistance, meaning that they are ideal for structural steel. Polyurethane coatings provide high UV resistance and flexibility. They are suitable for exterior surfaces exposed to sunlight. Inorganic zinc primers provide cathodic protection for steel structures by forming a layer of sacrificial anodes. Marine grade coatings are specifically designed for saltwater exposure. These protect ship hulls, docks, and other marine platforms. And these are our sources.